Hello everyone, in this video I will show you how to differentiate a function and also some basic rules for finding a derivative of a function. So let's begin by understanding what differentiation means. Let me define a function y equals f of a as a constant and x to the power n. Now we have to find the derivative of this. So what we do is we write dy upon dx. This is the notation we use for finding the derivative. So we differentiate this term with respect to x. So we write d by dx of a times x to the power n, which equals, an easy way to understand this is we multiply this whole term with the power and then reduce the power by 1. It's easier to visualize it. We write n times this whole term ax and then reduce the power by 1, n minus 1, and there we have it. This is the derivative of this function here. Now let's understand this clearly with some examples. So I define a function y equals, let's take a constant 4 x to the power third. So to find the dy by dx of this function, we write d upon dx of 4 x third. We multiply 3 times 4 x and we reduce the power of 3 by 1, which gives us 4 times 3 gives us 12 x, and 3 minus 1 gives us 2. So 12x squared. This is the derivative of 4x cubed. Now let's take a different example. Let's name this as 1 and the next one as 2. So I define y as 3x to the power fourth plus 3x squared. Now what do we do here is we differentiate this term separately and this term separately. So we get d upon dx of 3x to the power fourth plus d upon dx of 3x squared. So from here we get 4 times 3 gives us 12 x, and 4 minus 1 gives us 3, plus here we multiply 3 times 2, we get 6 x, and then we reduce 2 by 1, so we get 1. This is our final answer. Now let's move on to some basic rules for differentiation. Now for this rule, if we were given y equals a as a constant and x, and we have to find the derivative of this, what do? We write d upon dx of a times x. So the derivative of this would be just a. Now how did that happen? We know that this here can be written as a x to the power 1. So if we use this rule over here, we get 1 multiplied by the whole thing, 1 times the whole term a times x, and power reduced by 1. So 1 minus 1, which is 0. We know that any constant or variable to the power 0 gives us 1. So we get 1 times a times 1. And this is the same thing I've written here. Let's move on. Okay, so the next rule is really simple. It says if you have to find the derivative of a constant, it always gives us 0. So y equals a constant 5. And if you have to find the derivative of this, d upon dx of 5, it gives us 0. Now be it any constant, let's say d upon dx of 10, this also gives us 0. Now let's take an example which combines all the 3 rules which I've mentioned before. Here's the question. Pause the video and give it a shot right now. Okay, so the solution goes like this. We have to find dy by dx of this function over here. So as I said in the first rule, we differentiate each of these separately. So we write d upon dx of 3x cubed plus d upon dx of 9x squared plus d upon dx of 2x plus d upon dx of 4. So if we differentiate this, we get 9 x to the power 3 minus 1, which gives us 2, plus 9 times 2 gives us 18, and 2 minus 1 gives us 1, plus differentiation of this would be just 2, and differentiation of a constant is 0. So this is our final answer. Let's move on to the next rule. Now, if we've been said to find a derivative of a function like this, 1 upon x to the power n, what would we do? We know that we can write this 1 upon x to the power n as x to the power minus n, and now we basically use the first rule. So we multiply the base with the power, which is minus n times x, and then we reduce the power by 1. So it's minus n minus 1. Okay, the next step in this would be minus n and x to the power. We take the minus convention common here, so minus n plus 1. Okay, it's understood till now. So now what we do is minus n. We all know that we can write 1 upon x to the power n as x to the power minus 1, minus n, and the vice versa. So we take this whole thing in the denominator, we get minus n upon x to the power n plus 1. So this is the derivative of this function over here. Thank you for watching. See you in the next video.